how do machine learning AI systems get biased introduced? The primary source is the world. The world is biased. The world is sexist. The world is racist. So if all your data was totally accurate, it reflected exactly things that happen in the world perfectly accurately, the data would not be biased, but the processes that we live in, the world we live in is biased. So just to be very clear, that's the major source of bias.
Data science, AI, and machine learning for good. That's Raeed Ghani of Carnegie Mellon University.
My work is at the intersection of all the machine learning, AI, data science buzzwords and all the social impact, public policy buzzwords. So the intersection of those areas. And most of my work is really, it's anchored around problems that I work on with governments and nonprofits around health, education, criminal justice, policing, transportation, environment. And then with those problems, I then also focus on research areas that come up around fairness, explainability, and also on teaching that sort of provides students experiential learning opportunities to tackle those problems with partnerships with governments and nonprofits.
Can you tell us why you're so passionate about this and why it's such an important set of issues?
For me, the starting point was really trying to tackle problems that a lot of these organizations are facing when they're trying to improve outcomes for society, for people. If we're trying to look at public health outcomes around improving people's health or providing people employment opportunities. So problems like, which kids might get lead poisoning and how do we act preventatively to reduce that risk, or which people might have unemployment. And what do we do proactively? What skills do we provide them? What support do we provide them? What people are going to be subjected to police misconduct, and what can we do, again, preventative things? That was kind of the starting point for me, is here are some big issues in society. How can we use data and evidence to help tackle these problems? But as I started getting into those problems, I realized that it wasn't off the shelf. It wasn't, we just built something and it works. It required a lot of new things that had to be done, and really trying to understand how do we do these things in an equitable manner, in an ethical manner, and not just do propagate the same old things that have been happening in the past. So it's really coming from kind of very much from a problem-centered, human-centered view of people are going through these problems. Can we help organizations better improve outcomes for them? And then running into challenges when doing that, and then tackling those challenges through these approaches.
So what are some of the core challenges that arise in relation to data science, machine learning, AI, and so forth?
There isn't a quite sort of a shared understanding of, I'm pretty inclusive in how I use these terms, right? For me, they're interchangeable. They're ballpark the same thing. Yes, ballpark, they're trying to all use data and evidence to improve decisions, right? That's, in that context, we sort of treat them very broadly. And I think when we go a little bit deeper, we sort of find that a lot of these technologies are very good at very narrow and very specific tasks and very specific contexts. Right? The narrower the task, the better these systems are going to be. They also heavily rely on data, and the data is often curated, again, very carefully by people. And they also heavily rely on a lot of design choices that are made by people. So as much as we think about these technologies as, they can do a lot of things, the fundamental approach, the way they work, is they rely on a lot of choices people make. Designers of these systems make, developers of these systems make. And that's where a lot of the challenges come around, right? Challenges around, will they result in fair and equitable outcomes? Will they be understandable by the people who are using them? And more importantly, who are being affected by them? Are they robust to changes? Just because some system is working today and being fair, does it then continue that way? Is it respecting the privacy of the individuals who are being impacted? Is it transparency involved there? What does transparency even mean when you're dealing with some of these issues that are not commonly well understood by people? Are they inclusive? Who is accountable for the use of these? The people developing them, the people using them, the people being affected by them. So there's a whole series of kind of ethical values that we want to design these systems to achieve. And the question becomes, what values should they be? Who should decide whose values? Who should be the stakeholders involved in eliciting these values and getting to consensus if they don't agree? And then how should we build these systems to achieve those values once you've figured out what they need to be? And those are a pretty massive set of challenges, based on what we've seen so far.
Can you give us a couple of examples of where bias or unequitable results arise because of these issues you were just describing?
There are places, we're all sort of used to seeing, and none of those places are not any different than what the human systems today are creating biases, right? So if you take healthcare as an example, there are a lot of systems being developed that are used to do things like early warning systems, early diagnosis of diseases. So some of the work we were doing a few years back with hospital systems was around, can we detect which patients might be at risk of diabetes? And we want to detect that early in order to provide the patients, the physicians can provide, lifestyle change support and try to kind of change behavior of people, so to prevent that from happening. Now, at that level, it seems, pretty. That sounds great. Like, why would we not want to do that? And the question is, if you've got limited resources to allocate to people in order to prevent diabetes, if you can only, that hospital has resources to kind of do additional outreach district programs for, let's say, 1,000 patients, which patient should they be? And so these AI systems kind of flag individuals as high risk, but they're going to make several types of mistakes. No system will be perfect. They might flag somebody who's actually not at risk. It's called the false positive, right? Or they might miss somebody who's actually at risk. That's called the false negative. And they make both types of mistakes. But if you make those mistakes randomly, you sort of miss some people, you flag some incorrectly. That's sort of the nature of these systems. But if you're disproportionately making mistakes on certain types of people who have systematically been disadvantaged, so take people, again, in the U.S. healthcare system, right, typically Black and brown people underuse hospitals. They don't have access to hospitals as much. They don't go to the hospital as much. They get underdiagnosed. It's sort of very well known. Now, while that's a fact, that when an AI system is built on top of that, propagates that. So if somebody is underdiagnosed, an AI system is going to basically even further underdiagnose those individuals and not flag them as high risk of something, which means now the physicians won't, in addition to what they were doing before, they'll even more not provide them with the support programs, with the interventions, and that's going to result in even more underdiagnosis. So that's kind of an example of a system that's built to replicate the past, which is what most AI machine systems by default are. Is you give it training data and you ask it, build a system that best replicates that data in the past. And now when new patients come to you, can you score these patients to flag them as high risk? If your historical data was biased in this case, because certain people are being underdiagnosed for various reasons, then your AI system will just propagate that. And that causes, issues around equity and fairness and leads to disparate outcomes for people who already are undergoing such issues historically. That's one example, but that repeats the same thing around criminal justice systems. If you're trying to use a system to figure out who needs mental health services or social services, and you might miss people disproportionately. Same for work that we're doing around child welfare or in education, after school programs to get students to graduate on time from high school. If we miss students disproportionately from certain backgrounds, that ends up hurting those groups disproportionately and making the inequities that exist today even worse.
Well, we have a couple of really interesting questions that have popped up on both Twitter and LinkedIn. And I'm just going to start taking them in order. And the first point is from Suman Kumar Chandra. This is from LinkedIn. And he says, can you give an example of how human intervention and choices will impact the outcomes that you were just describing, those negative outcomes?
What happens is, when we build a machine learning system, we make a series of choices. Let's say we make thousands of choices. And it starts by thinking how we formulate that problem. So there's a pretty popular paper now that came out a couple of years ago around healthcare. What that paper, what that paper was doing was it was predicting which individuals in the healthcare system will have additional healthcare needs, who's going to be more in need. And when they formulated that problem, you don't really have, when you build machine learning models, like one of the key things we use these things called labels or outcomes. And it's not as if outcome is handed to us. We formulate the problem and define an outcome. And in this case, what they thought was, the cost, how much did this person cost? How much money was spent on them by the healthcare system? Seems like a reasonable proxy for their needs. So high cost, high need. So let's just build a system that uses, the intention was to predict need. The actual design choice made was to predict cost because they thought it would be a proxy and a reasonable proxy. Now, what happened was when they built that system, it predicted who's going to have high cost. Well, it's going to, again, if the people there are going to be some people who will have high needs, but low cost because they didn't use the system very much. They needed the system. They didn't use it. The system failed them. They didn't have access to it. They didn't order the right test because they went to places they didn't do the right test. They didn't spend enough, or they were in areas where the cost was less. So now what happened was that while that system was predicting cost, the assumption was predicting need. And if we had formulated the problem different ways, if we had formulated it in additional ways to think about what are good proxies for actual needs instead of just cost, that's the very basic choice we made. But then additionally, we make choices around when we link data sources together. It's a common common component of most machine learning systems is we link different data sources. And we do this thing called record linkage or matching. When we do that, we make mistakes sometimes, right? We link people that shouldn't be linked together, and we miss people that should be linked together. Those mistakes are not random. Often people whose names are long with lots of consonants together get mistyped and mislinked. People whose names are very similar and common names like Joe and Mike, and they get linked together even though they might not be the same person. Ideally, that mistake wouldn't happen, but in practice, it does happen. And what happens if you link two people together who are not the same? You've added interactions. So you've added somebody else's information to this person's record. If you miss somebody, you've removed information. So if you're now applying for a loan and your name was not linked together, you might have had extra jobs and income that the system doesn't know about you now. And it might predict that you're not able to pay back this loan. You don't have the credit history and you might not get the loan. Or if somebody else with a similar name to you has a bankruptcy and you've linked their data together, now you've added a bankruptcy to your record. So how you link things together, the mistakes you make, how you design those things, how you think about, if you're doing simple things like we have missing information about people, somebody's income is missing, and we do something called imputation, right? Fill in missing values. If you don't think about it carefully and your data is, let's say, 80% males and 20% non-males, if you are a non-male with missing income, you might do something really naive and bad and just say, well, I'm going to take the mean of everyone. Now you've made non-males look a lot like males because 80% of data is male, and now you've imputed income. And that's not, none of those choices are inherent in machine learning in the data you got, in the problem you're solving. It's a choice that you made as a machine learning or AI system developer. And so what we do is in our projects, in our training, in our programs, we sort of discuss each choice we make at each step of the process of the ML process, the AI process, and talk about what are the design choices we're making, what options do we have, what are the ethical implications of each choice downstream, 2 months later, 4 months later, a year later, on the people who are being impacted, and try to kind of make those choices consciously to minimize that risk that we're taking at this point, as opposed to doing kind of an upfront or a retrospective. we do a continuous sort of ethics conversation around each phase of the project, so that these choices that seem very small have pretty high impact on ethical and equity issues when applied to people in these contexts.
Please subscribe to our newsletter by hitting the subscribe button at the top of our website. And if you're watching on YouTube, then you should subscribe to our YouTube channel. And we have a couple of questions now from Tim Crawford. And I know Tim, and he is very prominent in CIO circles. So Tim's first question is, he says, what is the impact of culture in driving AI, or is it the reverse, that AI is driving culture? So the interplay between culture, AI, and addressing the issues you've just been describing.
I think I'd sort of talk about two types of culture there, right? One is sort of the culture and society. Let's kind of sort of talk about those, right? One is the teams that are developing and designing these systems, that culture and that. The second is the society that these systems are being designed for. Ideally, those two have a high overlap. The people designing these systems are in the community that these systems are being designed ideally with and not for. So I think that, unfortunately today that is not true. Most of us developing these types of systems are not part of the communities they're necessarily being developed for, and they're not being developed with them, they're being developed for them. And I think that's sort of one dimension, I think, where we need to be careful about is we need to kind of develop the talent and the people who are working with communities that are being co-created with these communities, and they're kind of part of the process. And that's not the case today. So I think the other piece I think that's important to think about is a lot of these teams, we need to kind of have the right environment set up for these teams, the right culture set up, so that these types of discussions happen. Right. What we sort of often hear about is when people are worried about raising these types of concerns in engineering teams. Like, well, I have a concern about what some of the choices we're making because they might have ethical issues, and they don't have a good setup for bringing up these issues, for having a framework. So I think we kind of need to have the right environment to do this. We need to have the right people with the right training, so they know how to have these discussions, and then they've had them before. And I think in addition to that, we do need more processes and checklists, right? We need to make sure that we follow the process. Have we had conversations with all the stakeholders? We often talk to people, at least in lots of sort of spaces I work in, where working on these types of societal issues, we talk to people who are using the system, but we may not talk to people who are being impacted by the system. And having a process that makes them be a critical part of the process is important. And I think we're getting there. But we're not. We don't have a repeatable process that's sort of standardized in order to do that. And I think we need to get there. So I think the development, the sort of the tech and AI development culture of today is kind of very much sort of build things fast and fail fast and break things, and it doesn't necessarily work when we're dealing with fairly critical issues around society, around, again, health and education, criminal justice. We need to be much more conscious of the impact we're having on people and develop environments and cultures where this can happen much more responsibly.
We have a couple of questions on the issues of bias. So I want to go back to Tim Crawford has a second question, which is, he says, do you introduce new types of bias as you're trying to shape the data to remove the original bias that you're trying to address? So let's talk about that first.
Data is not the only, or in many cases, even the major source of bias in these types of systems. Right? If you sort of step back and say, well, how do machine learning AI systems get bias introduced in them? the primary source is the world. The world is biased. The world is sexist. The world is racist. So ignore the data. The data, if all your data was totally accurate, it reflected exactly things that happen in the world perfectly accurately, the data would not be biased, but the processes that we live in, the world we live in is biased. So just to be very clear, that's the major source of bias. Is that bias comes in, and the world generates data that embeds all of its biases in there. Then we make choices as system designers we use certain data sources because they're available to us. If I'm in a hospital, again, I'm going to use my EHR system because that's what I have. I may not go out and say, well, there are a lot of people in my community who don't come to my hospital. Maybe I should go collect data about them, with them, understand what I'm missing. Or I might have access to social media data, and I will just take that data and assume it reflects the entire world. So I make a lot of choices around data. And to Tim's point, I might introduce if I add a data source, I am reducing one type of bias, but I may adding another type of bias. The next source of bias becomes sort of the design choices I talked about, right? How my ML is working and what choices am I making there. The next source, let's say I've magically figured out some way of getting everything right up to now. The last piece in most of these systems is often is the human intervention, right? It's how did the physicians intervene? How did the social service worker intervene? That intervention, the action that we take, an employment counselor connecting somebody with a training program, or the after school program coordinator, enrolling a child into a program to help them graduate on time, or a health inspector going into a house and looking for lead hazards. My AI system can be perfectly fair, but that intervention can be unfair. What if I'm doing outreach for a program, for mental health outreach program? My outreach program is by phone in English. It doesn't matter how fair my machine learning model is. I'm going to disproportionately miss out on people who are not reachable by phone, that I don't have accurate numbers for, and that don't speak English. That's not an AI problem, but it's the impact of my system. So I think one of the things that we kind of need to keep in mind is, and it's not a novel idea. It's a pretty simple idea. Like, we're looking at a larger system of which our machine learning or AI is a tiny component. And we kind of need to look at the whole thing and not just focus on, let's make the data unbiased. Let's make our model unbiased. We kind of need to think about how do we measure the equity and outcomes of the people we're trying to help? And then how do we figure out which component of our system? Is it the human component? Is it the intervention component? Is it the designer component? Is it the machine learning component? And focus on the things that will kind of help us get there. I kind of went on a little bit of tangent because the question was around changing one type of bias might lead to another type of bias. And while you're right, you want to set up your framework in a way that you are auditing the types of biases you're introducing. You may never get to a totally unbiased system, but that's not the immediate goal. It's often, when we build a system, we want to compare that system to the status quo, not to perfection. And we want to sort of measure and say, look, is this system better enough than status quo for it to be worth implementing? If it is, well, let's get it there. Yes, we introduce some biases, we reduce some biases. Let's go through a process where we measure that change and figure out, is this change better enough to implement? And what's important is to figure out who should be part of that discussion, right? Who's impacted by it? Are kind of the primary people who's using it, who's going to be taking action on it? So if we set up our framework right, we should be able to make an informed decision about, is this other type of bias? Is it, again, are we better off than the status quo, than the system that's being used today? That's whether it's human-driven, machine-driven, or a combination. So that's at least how I think about it, is setting up that baseline based on today, trying to improve over that, measuring that, running pilots, and then seeing, is this worth implementing for now while we continue to improve and get towards that perfection that we want.
And Arsalan Khan, who is a regular listener of CXO Talk, and he asks questions that get right to the point. And he comes back and he responds to you and he says, okay, fine. So how do we avoid bias in the data and in the algorithms that power the AI? Given everything you're talking about, what do we actually do?
We do basically, three things, right? We develop we set up an audit process of our systems. So during the development process, when we're building our systems, we keep auditing them to see what biases do they have on which groups and how do they compare to the status quo. So that gives us an accurate assessment, as accurate as we can, of how good or bad is the thing that we've developed so far. If it's not good enough, if it's not better enough, if it's good, then we use a variety. There's a series of methods and tools that exist to try to reduce that bias. If the bias is coming from the data, we might need to collect additional data from sources. So we go out and collect and get data. If the bias is coming from design choices made, we make different design choices. If we've developed a model so I'll give you let me give you an example of a specific project. So this was work we were doing with Los Angeles, and this is with the city attorney's office in Los Angeles. And their goal was to kind of reduce the number of people who are coming back into the misdemeanor, so the recidivism, to the criminal justice system. And a lot of these people, they needed different diversion programs, different social services programs. And because they weren't being provided with those, they kept getting stuck in the system. And so the city attorney's office sort of said, look, if you can help us figure out which individuals are likely to be at risk of, coming back into the system, we're going to figure out programs for them that we can provide and connect them with, so that it reduces their risk of cycling through the system. And that's sort of a common project we've done with several different organizations, some in Kansas and some in other cities and counties, to help them do preventative outreach programs, mental health assistance programs, social services programs, to help people who may otherwise be at risk from the criminal justice system. And the first system we built was, they said we could help a couple hundred people a month. So can we give them a list of people who they should be prioritizing? The first system we built was focused on efficiency. The idea was, can we build a system as accurate as possible? So when we give them a list of 150, as many of them as possible are going to come back into the system, so that all their resources are allocated towards people, or as many of them towards people who are actually at risk. Now, you might call it the most accurate system, but if you think about from ethical values, it's an efficient system. It's maximizing the number of people you're helping with limited resources. When we looked at the system, we found that that it was accurate, but it was more accurate for white people than non-white people. And it turns out that in LA, the recidivism rate was much higher for non-white people than white. So we're starting with this recidivism rate for non-white, this one for white. And we have a system which is accurate, but differentially accurate. So now if you play it out over the years, it starts off by here and it's more accurate. So it's accurate for both. So it reduces the rate for both, but it reduces the white rate faster than the non-white rate. So you start with here and you increase the disparities over time in the recidivism rate. It is most efficient. 80% of these people come back, but it increases disparities. So we built option number 2, and we tweaked the algorithms to be equally accurate for both groups. So what is that? It was slightly less efficient, 2 percentage points. And here's what that did. It reduced recidivism rates for both groups, but equally. So it didn't decrease disparities, but it didn't increase disparities. So it kind of propagated in some ways the status quo disparity at a 2% additional cost. So we built option number 3, which was we increased the accuracy for non-white people proportional to their need. And so now, it was accurate for both, but more for non-white than white. So it started from the same place, but now this is what it would do. It would decrease the disparities and get to equity in recidivism rates. And it was about the same cost as number 2. So basically, we provided this menu option, right? Option number 1 focused on equity. It's 80%, efficient, but it increases disparity. Option number 2, equality, 2% less efficient, 78%. It preserves status quo disparities as an increase, as a decrease. Option number 3, same efficiency, but decreases disparities to get to equity. What do you want to do? Now, in the back, there's a bunch of, and I can point you to papers. If you search for Los Angeles fairness and my name, you'll see papers there that we've talked about where the technical details where we have to develop certain algorithms to deal with the bias in our models, in our predictions. But from the policy side, providing a policy menu and saying, well, here's the cost, here's the outcome, what do you care about? That's sort of a tangible thing you can do and work with the different stakeholders to figure out, what do we want to do? Now they ended up choosing to go with number 3, and that was sort of the right thing to do. But we often sort of don't give, business managers and policymakers these types of we kind of give lots of technical jargon and don't make it clear that, yes, there's a lot of technical stuff in the back. There's a lot of different algorithms we're using. We're doing a lot of bias correction things. But in the front, those choices are really policy choices. They're and they rely on the values you care about. And so our job as kind of AI and machine learning sort of design and developers really is mapping from the values to the code that we write and the models that we build so that the outcome is aligned with these values. And then the process has to be kind of much more inclusive. But that's kind of an example of a project where very tangibly we had to figure out sort of how to do this.
We then have a question following up from this is on LinkedIn from Suman Kumar Chandra. He comes back and he says, okay, given all of this, on the skill set front, what skills are needed in this field to add value in data-driven equity, fairness, justice, apart from the engineering skills?
Without the people who have these skills, we're not going to get there. And I think that's where the skills that you need, yes, you need the technical skills, the math skills, the data skills, the programming skills, engineering skills, but you don't need to be an expert in ethics. Like every machine learning person, maybe ideally every machine learning AI person is also an ethicist, but that's it takes years of training and experience. I think what we need to be aware of is we have to build teams that consist of people who have that training and that background. We need to be able to have a conversation with. We need to be able to be a little bit more people driven, right? There's another, the human-centered design is another buzzword, but that's something we need to learn how to do, because all of these systems that at least I'm talking about, they're designed to achieve certain outcomes for humans. They're designed for humans and to work with humans and to impact human outcomes. So working with the skills to work with communities, to understand their values, to reach consensus, to work with people, to work with social scientists, and a lot of the projects that I work on, I run a program called Data Science for Social Good that's actually going on right now, where we have about 24 mostly grad students coming in from around the world working on projects like this that I'm talking about. That set of students, they come from computer science, they come from social science, and they come from kind of stats and math and engineering, because we need those skills. We need people from design. We need people from. So I have sort of this. I usually, when I talk about these skills, there's a large set of skills that we need. We need understanding of law and ethics and communication and managing teams and managing programs and working with community organizations. And it doesn't mean we all have to be experts in all of them. We have to understand the need for them. And we have to be able to work with people who have deep expertise there and work in teams. So that's would be kind of my the mini answer is you shouldn't be you don't need to be an expert, but you need to be able to collaborate with people with those skills, bring them into your teams, be aware of that need, and be open to inputs. And I think the best way to do it, honestly, is to work with people like that. It's not, it's very hard to sort of pick up that skill set by yourself and be an expert in all of these things. But I think those of you who are sort of building teams in your organizations, having that set of people who have that collective expertise, can talk to each other, can work with each other. That's the recipe, at least we've found, that helps us when we embark on these projects.
Arsalan comes back and he wants to know about governance do we need, he says, since everyone is creating their own AI, do we need a broader governance structure for AI, even at the federal level or through a third party that determines which AI is good and which AI is bad from an equity standpoint?
I wouldn't say long-standing conversations because long in AI doesn't mean very much. But it's for the last couple of years that conversation has been happening. Right, some countries are farther ahead, some agencies are further ahead. Europe has been further ahead in kind of thinking about what are some of the regulations around governance. U.S. has been a little bit more distributed, right? So federal, every company has a few of these frameworks. Every city has at least one, if not more. Federal agencies have been starting to create one. A couple of months back, NIST, the National Institutes of Standards and Technology, they came up with what is a good start towards a governance framework for these. I think they're important. So there's going to be many of them. They are all going to be somewhat similar. I think one thing that we need there, that's kind of we're getting there. We're not there yet. Is they're all very high level. We will probably all agree with all of them, but they're not necessarily operational. They have lots of good frameworks, but now if you say, okay, what do I do tomorrow? Give me a tangible set of things that I'm going to do. They're not going to get you there today. They're working towards that. That being said, I think for me, in some ways, the very simple way that I describe sort of, like what AI is better than another AI? Well, it's the one that achieves the values we care about more reliably. Now, I'm just punting your question because I've kind of taken your question of building the AI and kind of put it on the value side, right? And the values I want is not an AI question. And so I think that's sort of the if we all agreed on this, here are the values we need to have in our system. We want it to be equitable for these types of people over this type of period for these types of outcomes, and we want to respect this type of privacy, and these people need to be accountable, and it needs to be transparent in this manner. If we achieve those kind of requirements, then we need to compare different systems and figure out, because the values already exist in if you take federal agencies, right? Take Consumer Finance Protection Bureau, take the Environmental Protection Agency, take Federal Trade Commission, take Food and Drug Administration. All of those agencies have these values somewhere. Those values are for their human-driven systems today. They know what needs to know. What is fair lending? What is unfair lending? What does the process for drug approval look like? What is violation of a hazardous waste disposal law? What is antitrust? All of the privacy. They kind of know the values. What they don't have expertise in, they don't have the people and the tools and the processes to do investigations, to do audits when AI systems are involved. That's what they're trying to figure out right now, is how do we do that? And they're making a good start. But a lot of the values exist, but we haven't kind of updated them to reflect the needs when the thing on the other side is not a human process, but an AI supported process, not an AI automated process. None of these things are automated. They're still ideally, and for good reason, should be collaborative. AI is supporting human making decisions. So I think that's kind of, the one that's better is the one that better helps you achieve those values. And the question is, can we design tools and processes, and can we train people to kind of create a system that's better able to evaluate that, to audit that, to compare that, and to monitor that? Because again, unlike a lot of other technologies, what's different about AI also is that it's not static. Even if it is static, the world is not static. So the world applied to an AI system will give you different results over time. So you kind of need to be constantly monitoring and updating. And so you kind of have to have the people who are also doing these updates.
What happens if policymakers are trying to develop governance frameworks, what have you, and they just simply don't understand the AI? What do we do about this? Very quickly.
You should work with them, collaborate with them, help them. They should be developing it in isolation, and neither should the private sector in isolation. I think this is a collaborative exercise. So we need to work together. And it needs to be a transparent and open process. It shouldn't be just built on the side and thrown over and saying, this is the governance process. So that's kind of my very short answer.
Arsalan comes back and he wants to know, he says, we know AI has great potential, but how do you avoid people who veto the recommendations by the AI? Or what do you do when the AI is making a recommendation? You know, as an expert, it's the right recommendation, and the people who are in charge are saying, no, that's wrong.
It's not an autonomous system that's making a decision. It's supporting a human. And sometimes the AI is right and the human can use that help. Sometimes the human is AI. Many times, most of the times, the AI is wrong and the human needs to be able to override the AI. And I think the question becomes, how do we design our systems to not be this one shot? I'm gonna give you a decision. I'm gonna give you a recommendation. But really, I think the AI that I've, as I talk to, caseworkers, social service workers, unemployment counselors, high school counselors, and people in the front line, people who are doing really important work, who we want to support with these tools, they don't want an answer. They want more information. They want to make an informed decision. And I think the way to design these systems is to be much more collaborative, to have a conversation with them and say, we think this, I think this is the recommendation. They might ask and say, well, why do you think so? It was because of this. Like, yeah, but last time we did this to this person, here's what the outcome was, didn't work for them. Like, yeah, but this person is, so it's really, think of it as designing these systems to be much more interactive, because the way I look at it is, if I build a system, it can be, as you said, 100% accurate. And if the person taking the output doesn't, every time it overrides it, then my impact is zero. So I need this person to work to sort of to take action, but only when that action is the right action. And I think today's AI, at least in these areas that we're working on, isn't reliable and robust enough for me to say, I want to build something that you follow every single time blindly. I don't trust it. It's not there yet. So I really want this to be, explainable and transparent. It's not just transparency, because transparency doesn't mean, comprehensibility. So I want something that this person can interact with, figure out when it's wrong, why it's wrong, override it when it makes sense, correct it when it makes sense, follow it when it's right, and really together get towards outcomes that we want. And that's not easy. That, what I'm saying, building is not easy. But I think it's too dangerous to sort of say, I trust my system is right all the time, this human just doesn't follow it. That, I don't know if that AI system that is so good, so right, and only if I change the humans. And so I think we need to develop things that are a little bit more aware of their uncertainty, a little bit more aware of, when they're right, when they're wrong, able to explain a little bit of their reasoning in order to help the human collaborator better assess its limitations and its benefits and take action. At the end, we want the right action to be taken, regardless of where it came from. So that'd be my advice there.
What advice do you have for folks on the subject of, I'm laughing because I want to see how you respond to this one. In one sentence, algorithm, transparency, and explainability. What advice do you have?
Figure out what you need this transparency and explainability for. What's the purpose? What's the goal? Who you need it for? Who is the consumer of this? And how are you going to measure if your system is transparent and explainable? And anchor it on a real problem. Don't do something abstract. Take a problem that you're trying to solve in that system. Figure out who's the user that you want this transparency explainable for. How would you evaluate it is transparent and explainable? And what does that help you achieve? And there's some papers that we have that sort of go a little bit more into how you do that. So happy to point people to that if you're interested.
We have a lot of technologists and data science folks listen to CXO Talk. What advice do you have for technologists, including chief information officers, on the topics of fairness and equitability and what they need to focus on? And again, just in one sentence, please.
Build your teams to have this collection of skills and expose them to the entire flow from what is the goal of the product or the service you're developing, the formulation of that, the data source identification, the development of it, the evaluation and the monitoring and the deployment. Right? We often silo our people and we keep them in very single disciplinary. If we want to sort of build these systems that have high impact and equitable impact, we need to broaden the teams and, make the teams much more diverse and inclusive to reflect the problems we're working on, but also give them visibility on the entire chain, because the more they have that, the more they're equipped with having the right environment, and the more likely they are to produce outcomes and systems that we care about.
Okay, and with that, we are out of time. I want to say a huge thank you to Raid Ghani. He is with the Machine Learning Department in Computer Science at Carnegie Mellon University. Raid, thank you so much for taking time with us today.
No, thank you. This questions and conversation was great. So thanks for having me here.
And a huge thank you to everybody who watched. Your questions, as always, are phenomenal. You're a great audience. I learned so much from you guys every single time. I feel like I'm the proxy or the channel for you guys who are watching. And so lucky me and lucky you for getting to ask questions as well. Now, before you go, please subscribe to our newsletter by hitting the subscribe button at the top of our website. And if you're watching on YouTube, then you should subscribe to our YouTube channel. And we'll keep you notified, and you'll get to hear about all these great upcoming episodes. Everybody, thank you so much for watching. I hope you have a great day, and we'll see you soon.